Alright, so y'all go ahead and do the factoring and the math knowledge question, pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So we're going to start by removing the 6 and multiplying it by the 45. And so we're going to have x squared minus 17x and then minus 270. The two numbers that you're going to want to use are going to be negative 27 and positive 10. So you're going to have 6x minus 27 and then 6x plus 10. This set will divide by 3, and so we'll have 2x minus 9. And then the second one will divide by 2, and we'll have 3x plus 5. And so this would be your answer to your factoring. For the math knowledge question, working as a summer intern for a state senator running for re-election, she is in charge of ordering election signs. The cost of printing election signs includes a $15 fee and then plus 33 cents for each sign printed. Which of the following is the cost to print X signs? Well, we always have a $15 fee, and so we're going to have 15, and then we're going to add 33 cents per sign. And so that is given by D. We have our $15 fee here, and then we add 33 cents for the number of signs that we order. So we're looking at lesson 85 today. We're looking at cross sections of solids. So hopefully after this lesson, you will understand how to deal with cross sections of solids. So a cross section is the intersection of a three-dimensional figure and a plane. So we're going to have a solid three-dimensional figure, and we're going to have a plane, and they're going to intersect somewhere. And where they intersect is your cross section. So if you look here, we have a cylinder, and then we have a plane. Do y'all see where they intersect? They intersect here. And so the intersection of this would be a circle. Okay, so that is what a cross section looks like. Now, if we turned it the other direction, we've got the intersection right here. And so that is not a circle, that's a rectangle there. Okay, so those are the two ways that we could intersect it. You can intersect it a bunch of different ways as well. It just depends on what they give you for the plane and the solid as to what kind of cross section you'll have. So look in here, it says to describe and draw the cross section of each solid. Well, if you look here, the cross section is the figure that's right here. So what shape is that? It's a square. And so now you just need to draw your square. And so there's my square that I drew. For this one, if you look, this is the cross section here. So it is a 5-sided figure, which is a pentagon. And so then you just need to draw a pentagon. Okay? Looking at the next one. If the plane shown is perpendicular to the altitude, find the circumference of the circle in terms of pi. So it wants us to find the circumference of this circle here. We want to find our circumference. Well, it's the same as the circumference that is found here because it's the same circle. It's just further along the cylinder. So our circumference formula is just 2 pi r. So we have 2 pi, and then our radius is 5. And so we would have 10 pi. And it said in terms of pi, so we leave it as 10 pi. And then the units on that are just going to be centimeters. And so that'd be your answer. Let's look at another one. The altitude of the cylinder lies on the plane shown. We want to find the perimeter of the cross section. Well, the perimeter, I'm going to do it in red so you can see it a little bit better, of our cross section. The cross section is this one that I'm outlining in red. Okay, and so what shape is this? It's a rectangle, and so we need to figure out what is the length and the width of it, this part right here is the diameter of our circle. And so the diameter of our circle is 10. So this would be a 10, which means this bottom part is a 10. And then the height is the same as the height of the cylinder. So that's 20. And so this side over here is also 20. So the perimeter, if you add all your sides up, is a 60. And then we have centimeters. So that'd be the perimeter of your cross section. Looking at another example. We want to find the area of the cross section of a right square pyramid. The pyramid is 7 inches tall and the base is 8 inches on each side. And the cross section is perpendicular to the base of the pyramid. Okay, so we have a pyramid that has a square base. And then we've got it going up here. And then the cross section is perpendicular to the base. So this is the base. So the cross section is going to go through this in the middle. And then it's going to come up to the vertex and then go back down over there. And so this figure is a triangle. And this length right here is the slant height. Okay. So we know that this base length here is 8 because it's the same as the length of the sides. Now if you look at this part here, I can draw my triangle from the center up, and then that's my slant height, and then that's half of the length of the base, so that side's 4. The height of the pyramid is 7, and so to find this slant height here, we're going to use Pythagorean theorem. So we would have 7 squared plus 4 squared equals the hypotenuse squared. And so if you solve that using Pythagorean theorem, you should get about 6.6 for your hypotenuse. And so for your area, oh wait, we didn't even need that. I was going to find the perimeter. Well, that'd be for your perimeter. You'd have a 6.6 and then a 6.6 and an 8. But for your area, sorry, we're going to do 1/2 base times height. So here, the base length is 8 and then the height is 7. So we have 8 times 7, and then half of that would be 28 and then inches squared. So your perimeter, I'll go ahead and tell you what it would be. 21.27 if you wanted to check that out. But your area would be 28. That's what it had asked to find. Okay? Looking at Cavalier's principle, if two solids lying between parallel lines have equal heights and all cross sections at equal distances from their bases have equal areas, then the solids have equal volumes. So they're lying between parallel planes. So these are on the same plane, and then the vertices are on the same plane. And then the height is the same because they are between two parallel planes. And then the cross section, if I drew a parallel plane, the cross section here and the cross section here are the same, and it's the same all the way up, then that means that the solids have equal volume. We've kind of dealt with this with oblique figures where they've been tilted a little bit. The volume doesn't change when you have an oblique figure, okay? It just makes it tilted just a little bit. So we're going to use this example. There's a stack of CDs on a desk, and the stack is bumped and makes an 80-degree angle with the table. And it wants to know what is the volume of the stack. So for the volume of a cylinder, we're going to do the area of the base, which is pi r squared, and then times the height. So pi, the radius on this one, well, they give us a diameter of 4.75. So the radius is half of that, which is 2.3 4.375. And then our height is 4.5. So if you go ahead and multiply that out, you should get 79.74. Okay, and so that would be the volume for your stack there. Looking at this lesson practice, y'all go ahead and see if you can figure it out, and then unpause the video and I'll tell you the answer. So it asks for the shape of the cross section. Well, we have this figure right here as our cross section, and that's a hexagon. So what's the shape of the cross section? A hexagon. Okay. Looking at B, it says to find the perimeter, and it says that the base is a square. So if this is a square, that means that this one is also a square. And then it says one side is 4, so the perimeter of it, 4, 4, 4, 4, a total of 16 inches. Okay. Looking at C, find the perimeter of the cross section of the square pyramid. So it tells us it's perpendicular to the pyramid's base. This is the figure that we were kind of looking at earlier, where we were supposed to find the area, and I accidentally found the perimeter. So that's the figure that you would be looking at. The height of the pyramid is 14, so that means going from here, coming down is a 14. Makes a right angle there. And then the base length is 12. So this total part here is 12. So this part here is a 6. And so to find the perimeter of our cross section, we know that this base part is 12. So our perimeter is 12. And then we've got to find the other parts. So we've got to find this slant height here. And so the way we're going to do that is using Pythagorean theorem. So you're going to say 6 squared plus 14 squared equals your slant height squared. That's this one. And so 6 squared is 36. And 14 squared is 196. So if you add those together, you get 232. So then you take the square root, and you get 15.23. And so we're going to have 2 of those. I'm going to move this down a little bit. So we're going to do 12 plus 15.23, and then the same length is going to be this other side of our triangle. So we're going to do 15.23. And so if you add those together, you should get 42.46. And then inches are units, so that would be your answer there. Okay? Looking at D, find the area of the cross section. So y'all try this one and then unpause the video and I'll go over it in case you couldn't figure it out. So the edge of the cube is 4 centimeters. So this length here is 4. This length here is 4. Now this length is not 4. It's not an edge of the cube. It's actually a diagonal of a cube. And so if you look, I'll draw it in red here. This triangle here is actually a right angle here. So we have a right triangle. And then this is a 4 because it's an edge of a cube, and this length is a 4. And so we need to find this one. And if you do Pythagorean theorem, you'll get 4 square roots of 2. And so to find the area of the cross section, we're going to do 4, because that's one of the side lengths, and then the other side length is 4 square root of 2. And so if you multiply those, you have 16 square roots of 2, but it says to the nearest 100th square centimeter, and so if you multiply that, you get 22.6 3, and then centimeters squared because you have area. Okay, so that's how that one would work. For the next one, find the volume, and it says exact volume for the cone. So volume formula for a cone, 1/3 area of the base times the height. The area of the base is pi r squared times the height. So we have 1/3 pi. Our radius on this is, I'm going to move this over just a little bit. It's 2.5 centimeters. So we're going to have 2.5. And then our height is a 12. Okay, so we have a 2.5 for our radius, and then we have a 12 for our height. So 2.5 squared is 6.25. So we have 1/3 pi, 6.25, and then times 12. So if you multiply by 12 and then divide by 3, you end up getting 25 pi. And it says exact volume. So this is the exact volume when it's in terms of pi. And so our units are centimeters cubed. And so that would be your answer there. Okay? So now we're going to look at the challenge question. We have the conical top section of a cone is cut off, revealing a circular cross section. The remaining part of the cone is called a frustrum. And we are actually going to look at frustrums later in the year. They want to describe how a plane could intersect a frustrum to make the following cross sections: a trapezoid and a triangle. So y'all pause this and kind of think about it, see if you can figure out what it would have to do to make those two planes. To make those two figures for your cross section, and then I'll go over the answer for you. All right, so here is an example of a frustrum of a cone. And if you wanted to make a trapezoid, it would just need to be going through both of the circular bases. And so it could look like this. And that would make a trapezoid there. If it cuts down through both circular bases, that's how it would make a trapezoid. And so it could be going this direction, or it could be slanted more this way, but it has to go through both of your circular bases. Okay? For a triangle, it's going to be a plane that's tangent to the smaller circular base, and it cuts down through the second one. So if we put it right here, and then it's going to go over to here, that would make a triangle there. So it would need to just touch at the top and then go somewhere through the bottom base. Okay? So hopefully that makes a little bit of sense for you. Your homework is 1 through 30, so you need to make sure to do that tonight so that we can go over any questions that you have tomorrow.